AltConf. Hope you guys have been enjoying the conference. My name is Andy Trice, and with me is Jennie Oliver. And as we were just introduced, we're both architects with IBM. And today we're going to talk about scalable iOS applications with serverless and Kubernetes. So just by a show of hands, how many people are familiar with Kubernetes? Okay, that's actually more than I expected, but that's good. And how many people are familiar, at least marginally, with serverless? Okay, and how many people are actually using those right now? Okay, that's more like what I expected, a much smaller number of hands. So what we want to talk to you about today is just, what these concepts are, how you can use them within your applications. There's only so much we can do covering both of them in 45 minutes, so we'll do our best, and there'll be some time at the end for questions and answers. So first of all, why are we talking about back-end systems at a primarily front-end developer conference? And really, it's pretty obvious, but if without a back-end system, there's only so much that we can actually do. We'd be stuck making, I don't know what, like fart sound apps for our phones and not doing anything actually productive with them. Because the back-end is your gateway for information. It's how you, without a back-end system, you're not going to be able to trigger push notifications. You're not going to be able to deliver data. You're not going to be able to capture data. So it's essentially the backbone that makes everything work. And when we're talking about Kubernetes, we're talking about serverless. One of the primary things that we also want to address is the concept of scalability, or, as we can read here, the capability of a system, network, or process to handle a growing amount of work or potential to be enlarged to accommodate that growth. So I'm sure every one of us in this room has been in a situation where we've had an app and it's come under load of some kind, and then the system is under a lot of stress to actually keep up with that load, or it can't accommodate that load and fails altogether. I'm not saying it happens with every app. I'm not saying it happens in every single use case, but it does happen, and it happens quite often. And by choosing either Kubernetes as a back-end platform or serverless as a back-end platform, you can build your apps, structure your apps in an environment that inherently scales to meet the need, regardless of it's, you got 10 users hitting it or you've got 10 million users hitting it. So I mentioned Kubernetes and serverless, so we're going to go ahead and dive into these now. And I'm going to hand it over to Jennie to talk about Kubernetes, and I'm going to come back and talk about serverless.
Okay, so to understand Kubernetes, you first have to have a good understanding of containers. So containers are a standard way to package your application and dependencies so that they can be moved between environments and run without changes. They work by isolating your applications inside the container so that everything outside of your container can be standardized. So a container contains your app and all of its dependencies. They're well secured, meaning that everything that happens in one container is completely isolated from what's going on in another container. Docker is the leading container platform in the industry. Docker allows you to package your application and dependencies into a single image so they can be deployed consistently across many environments. Docker images are immutable layers, enabling immutable infrastructure. So committed changes are stored as individual read-only layers, making it easy to reuse your images and track changes. So you can create and run your Docker containers by instantiating these immutable images. To build your own image, you start with a Docker file, which has a simple syntax for defining the steps to create your image and run it. So each instruction in a Docker file creates a layer in the image. When you change your Docker file and rebuild the image, only those layers that have changed will actually be rebuilt. So this is part of what makes Docker images so lightweight, small, and fast. It's also helpful to compare containers to virtual machines, which many of us have used for a long time. So a virtual machine has its own operating system and its application and dependencies, compared to a container which shares the same base kernel with other containers. So in a virtual machine, It has its own operating system, and the VM talks to the hypervisor layer, which talks to the hardware. The stack is a lot bigger. It's a lot less efficient than a container. One key difference is with containers is that they're task-oriented. So a good analogy here is an app running on your phone. If you start a container, the task runs. When the task is finished, the container stops as well. As opposed to a VM that has its OS up and running, is sitting there consuming resources, waiting for instructions from you. So containers allow you to share the host operating system, which reduces duplication, still providing the isolation that you want. It also allows you to drop unneeded files like system libraries and binaries. So this saves space and reduces your attack surface. So if SSHD and libc aren't installed, they can't be exploited. So containers are awesome, and that brings us to Kubernetes. Kubernetes is an extensible open source platform for managing your containerized applications. You may see it referred to as K8S in writing. That 8 stands for the 8 characters that are dropped between the K and the S. Kubernetes means helmsman or pilot in Greek. So you can think of it as the captain of your ship with all the containers. It actually comes from Google. Their internal system, Borg, is what they've been using since 2002 to manage their millions of containerized applications. Google actually realized early on the potential of Docker images and sought to deliver container orchestration as a service on their cloud platform. So instead of using code from their existing systems, they designed Kubernetes from scratch, and then open sourced it. They created the Cloud Native Computing Foundation and donated Kubernetes to it, and making them less of a primary influence on Kubernetes. So shortly after that, a bunch of other companies joined the foundation: Red Hat, IBM, Amazon, Microsoft. And one of the first major users of Kubernetes was Pokemon Go, which is kind of fun. So the key paradigm of Kubernetes is its declarative model. The user provides a declared state, and Kubernetes does its best to make that happen. So if you need 5 instances of your application, you don't create those instances. You tell Kubernetes to do it, and it takes care of everything automatically. If something goes wrong and one of your instances crashes, it will recognize that and spin up a new instance on an available node. So as an app developer, when would you want to use Kubernetes? So say you have your app, you've been using Docker containers, and you have a few servers, and everything is fine, totally manageable in your brain. And say your app gets picked up by a news source and suddenly gets a huge influx of utilization, and you need to scale from 3 servers to 40 servers. This is when Kubernetes would be really awesome. Kubernetes also has some great monitoring tools, so I'm hopefully going to be demoing that in a minute. Kubernetes runs multiple connected containers organized in pods, running on different hosts where continuity of service is guaranteed. It is evolving very fast. They release every 3 months. This is a basic architecture diagram of Kubernetes. There are 2 main building blocks. You have your master and 1 or more worker nodes. So you feed the master your configuration file, which is in the form of a deployment YAML, and it runs the configuration in your infrastructure. So you can tell it number of CPUs or RAM or file storage requirements that you have, and it will keep track of that for you. Each worker node, that's the other major building block, has a kubelet to communicate with the master. And some other nice features: there's load balancing in front of the nodes, automated health checks, and rolling restarts. So nothing is cut off from your service if you need to restart it. Kubernetes is by far the de facto standard for container orchestration in the industry. Every major cloud offering has a Kubernetes system. IBM Kubernetes services, obviously, Amazon ECS, Google Container Engine, Azure Container Service. There are other container managers on the market, such as Docker Swarm, Apache Mesos, Red Hat OpenShift. They're much less popular, not as commonly used. So I'm going to hop over to IBM Cloud and do a quick demo of creating a new Swift BFF and deploy it to a Kubernetes cluster. So we have this console for Apple developers. These are all apps that you can create very quickly. It's our collection of starter kits. Front-end or back-end apps, depending on what you're doing, and you can add various services and resources. And these starter kits actually build or provide you with all the files you need to deploy to the cloud, Kubernetes or Cloud Foundry, whatever you are doing. So I'm going to create a Swift backend for front-end API. It comes with some persistence with CloudInt. This all looks good. I'm going to create this app. So we'll just take a quick second here. All right, so at this point, I can download the project and open it in Xcode and continue development. Right now, I'm actually going to create a delivery pipeline. I'm going to hit deploy to cloud. I have a pre-created Kubernetes cluster here. And this will take a couple minutes to create my toolchain. Just in the interest of time, I have another Swift BFF that I created just before this here. So my toolchain's created. I'm going to view my toolchain. And we have a lot of stuff that was generated here that's very cool. There's a GitLab repository with all of my code here. So you can see here's my package Swift and my backend, my Katura backend and sources. My Helm charts. Helm is the package manager for Kubernetes. So if you were to manually change your deployment, this is where that would happen. And what's cool about this is you can change your source code, save it, and with our pipeline, it will automatically be built and redeployed. So we have continuous delivery here. Okay, so once the project is built and deployed, everything is green. I'm going to take a look at the deployment logs here. Scroll down to the end, looks like finish success, and I have a URL here of my application. There we go. There's my Katura server up and running. Okay, so then so this is running on my Kubernetes cluster. I'm going to move over to my Kubernetes dashboard now to show the monitoring available. So if I could select workloads here, so you can see CPU, memory usage, all the pods that I have up and running here, lots of pods, lots of deployments. So that's about it. So that's about it for Kubernetes. I'm going to hand it back over to Andy. Let's talk about serverless.
All right. Thank you, Jenny. So that was a quick crash course in Kubernetes to introduce it. And now I'd like to take the opportunity to talk about serverless. And in particular, I'm going to talk about this in the context of IBM Cloud Functions. It is our serverless runtime on IBM Cloud, which is based on Apache OpenWhisk. So it's an open source project OpenWhisk actually originated as a project with IBM, contributing to the Apache Software Foundation. And I know that there's contributions coming to OpenWhisk from Adobe, as well as Red Hat, and possibly a couple others. But anyway, basing this in the context of IBM Cloud Functions. So there's two things to really kind of make up a serverless deployment. One is that the cloud provider manages the allocation of resources. So when we're talking about serverless, we're not talking about like there's a non-existent server, because there has to be that central thing that your application talks to. But the advantage of serverless is that you don't have to manage any of that yourself. You don't have to worry about setting up whatever processes might be running on the server. You don't have to have like a monolithic architecture. You don't have to worry about how many instances are there, how are they going to scale, what is the network connection across all of them. When you are working with serverless applications, you focus on development and deployment at a granular level. And when I say at a granular level, I mean you are literally, you can have it down the scope, or you've got like 5 lines of code, or 3 lines of code, whatever it is, on a per function level, and say, I have a function, I want it to be executed on the server, and so I'm going to deploy it as a serverless action. And it can be, with IBM Cloud Functions, it can be in any number of languages. I've got another slide further along that shows all of them. But primarily, right now, in a few minutes, I'm going to show you an example in Swift, but it could be Node, it could be Java. I forget all of them, but we'll see the list in a minute. But the other thing is, if it's not a language that we support directly as being able to deploy, pardon me, being able to deploy as a function, you can also deploy a container. Because when these are being executed, they're basically being executed as containers. And they're executed on, scaled up and executed on demand. So as your need for them increases, more containers containing your functions will be spun up, more instances will be spun up, and your application will scale without you having to do a single thing. So let's get into that a little bit more. When to use serverless. Essentially, you can use serverless when you have any piece of code or any piece of logic inside of a container that you want to be executed whenever it's needed, and literally at any scale. This could be, happening once a week. It could be happening, 1,000 times a second or more. And the system is going to scale and handle everything based upon whatever the needs of your application are. And, well, I'm starting to jump ahead of myself. So the code is run on that on-demand basis, with no management of assets, no management of infrastructure, so that you as a developer can focus on building or solving whatever problem you need to solve and building the tools that you need to make your app successful. So if you need it to just be like a simple database CRUD operation, you can do that. If you need it to be something that is triggering an action or triggering some kind of notification or handling triggers that are coming into the system and then delegating or performing some other logic accordingly, it can do that. And it can scale based upon whatever that influx of operations is, literally without you doing a single thing. And I've got another slide to emphasize that again. It transparently scales with the number of requests being served. So what happens with the Cloud Functions is when you do a deployment, it deploys it. You have a certain number of containers that certain number of instances per function. I'll call them containers because actually they are containers under the covers. But a certain number of containers get spun up under the hood that can respond to your requests. And as more requests come in, more instances of those containers will be spun up based upon whatever the needs are. And when they're no longer in use and the demand drops, then they get reclaimed. And so one of the things when you're doing Cloud Function work is that if you have a lot of hot containers, meaning they've already been instantiated, they've already been set up, code in there has already been compiled, if it needs to be compiled, then it's going to respond instantly. If you are spinning up more instances, then if there's any kind of initialization start time for your container, then there might be a request that takes 10, 20 seconds for that container to be spun up, if it's a cold start for a container. So that's one of the things you want to keep in mind when you're doing this, if you're working with serverless. But depending upon how your code's structured, if it's pre-compiled before it's been deployed, that may or may not be an issue. Another aspect of serverless that's very interesting is that you only pay for resources being used instead of like resources that are idle. So when you have a server process that's constantly running, I mean, you're paying for the compute resources for that process, even if nobody's actually accessing it. With serverless models, so you deploy on a granular level and you pay on a granular level. So I can't remember if I have a slide in here or not, but it's based upon the execution time, the amount of memory, and the number of instances, I think, that are spun up. And based on that, like, so you only pay for what you're actually going to be doing. Now, that leads into another topic when you think about, well, are there certain tasks that it might be better at or worse at than other kinds of deployment models? And that actually is the case, because if you think about something with serverless action, by default, the timeout, I think, is like 60 seconds. It's configurable, but you don't want to necessarily use serverless for very memory-intensive, very long-running tasks, because if you do, you're probably going to end up spending a fortune on it. But if you're just doing like database read-write and you need to have it handle, like I said, 10 requests in a minute or 10,000 requests in a second, it can scale based on whatever that need is without you doing a single thing. So with a traditional model of an application, when it's considering scaling, there's always going to be some kind of process that monitors it, whether it's doing a poll or, I don't know, some kind of venting. But basically, there's the server process, then there's the monitoring process and the communication between them. And when the utilization of the server process gets to a certain threshold, another instance of the server might get spun up. With the serverless model, this is all transparent to us. There's no overhead for resiliency, no wrong running processes to monitor the state of a server application. And essentially, it's just that based on the load coming in, the system handles it accordingly, and that's built into the serverless platform itself, not something that you have to worry about with your applications at all. The other thing that's interesting about serverless is it introduces an event-oriented programming model. So you can be making requests to this like a traditional API, or you can have your serverless actions responding to events, so things that are happening from an event provider. And that might be every time data is written to a database, it triggers an event, which triggers a serverless function. You can do an operation based upon data coming in. It could be data coming in from an input stream. It could be some kind of notification. I have another slide that will show a couple more of these different models. So one of the other things I mentioned earlier was that pretty much any language is supported. So up top, we have the natively supported languages in this slide for IBM Cloud Functions, where if you want to write your functions in Node, Swift, Java, Python, or PHP, you can do so without having to do anything special. It's literally just like writing a function call as if you're writing it in a text file on your local machine to be executed locally. And that can be deployed at that granular level. But if you need to do something else, and let's say it's like Go, C, Rust, you need specific libraries compiled in for very specific actions, you can create a Docker container that is configured for Cloud Functions that includes all these dependencies with your code in any language, and it can be executed in that same serverless fashion, where it's taking advantage of the platform so that it will inherently scale and you don't have to manage any of the actual underlying server resources. Serverless actions can also be invoked in different ways. So there's a blocking request, meaning you make a request, it waits for the processing to be completed, returns the result back to your app or whatever's requesting it. And this is probably the more traditional for like a CRUD operation. It can be non-blocking, meaning an event comes in or you make a request, then that triggers whatever your compute action is inside your serverless function, and then it just returns immediately. So it doesn't wait for the action to actually finish. It just says, hey, I'm done. Your app keeps on doing whatever it's doing while that operation is happening in the background. Or they can be set up periodically. So if you have a task that you need to happen every minute, every 10 minutes, every day, whatever that might be, you can set up your serverless functions to operate in that fashion. And again, pardon me, you don't have to set up anything special or any kind of like server management aspect to do this. What's also interesting about serverless functions is that, and this is particular to IBM Cloud Functions and OpenWhisk, is they support higher level programming constructs, meaning you can very easily create sequences of actions. So you could have one request be to a sequence, and that sequence actually be a composition of, let's say, 2, 3, 5 different serverless actions, so it can perform, so you can still deploy your code in discrete actions and then sequence them together for that complex sequence, or more complex sequence based upon whatever you needed to do. And in it, kind of to go with that of being able to bind actions into sequences, you can also bind parameters, so that every time that you make a request, you don't have to be passing like credentials, or if there's something that's going to be really common to different requests for specific applications, you can bind that parameter either to a function or bind that parameter to a namespace. Sorry, they're not called namespaces, they're called packages in Cloud Functions. So you can bind the parameters to the function or to a package, and then when you invoke it, you don't have to be passing those like credentials or whatever might be kind of like secure you don't want included in every request. You can bind it there, and then it just lives in the Cloud Functions environment up on the server. So I touched on earlier the aspect of serverless being event-driven. There's an open interface to hook into event providers. I would love to give you more detail on that, but actually that's not one of the pieces that I focused on. So one of the things I can say is that we have event providers on IBM Cloud that you can hook into out of the box within minutes and be set up and be responding to events from any of these systems. One of them being the periodic. So based on whatever unit of time you need, it'll run the task whenever it needs to. CloudInt, which is our NoSQL database. And you could set it up so every time you read from the database or every time you write to the database. And I've used this in particular every time data is written to the database, having that trigger an action to do kind of like a streaming analytics operation based on all data coming into the database. It can be driven from message hubs or API gateway notifications, GitHub. So for GitHub, you could do a commit to master triggers a serverless action, which can do some kind of other operation, which, you know, who knows what it needs to do, but maybe you need to do a push notifications out to your app's users and say, hey, there's a new version out, I don't know, something like that. But there's a lot of different event-driven event providers that we have on the cloud already, but that is extensible, and I just want to reinforce the fact that it can be transactional, meaning like you're making a request through an API gateway, like a traditional REST request, or it can be all event-driven. So based on whatever's happening in the system, it's triggering other actions that can make an impact on whatever problem you're trying to solve. So with that, let me go ahead and switch over for a demo. And right here, we're looking at the Cloud Functions starter page. And the first thing that I want to do, oh, that's interesting. I guess you have to end the slideshow before you switch. Okay, now we're looking at the Cloud Functions starter page. Let me go ahead and make this a little bit bigger. Oh, there we go. And the first thing I want to do is create an action, just because I want to show you how easy it is to deploy a single action. So we'll go to create action. We'll call this Hello World 2, because I know I created a Hello World earlier. And create package. Oh. Just put it in the default package name. Oh shoot, wait a minute. I didn't mean to do that. We want to hit create down here at the bottom. So in this case, I just created a Cloud Function, and in this one, I just chose the default, which was Node.js. And we'll go ahead. I was not kidding when I say 3 lines of code to deploy an action that can be run on the server. If you guys can't see it, let me see if I can zoom in on this a little bit. You can see here, there's literally function main, parameters being passed in, and it's returning the message hello world. So let me go ahead and invoke this. And you can see we've got a response. So that was creating a serverless action, deploying it to the serverless infrastructure, and then invoking it, and that was from a cold start for our Node.js actions, and we got a response right here in the browser. Now, I can take that, I can deploy it through our API gateway, so it's a REST-based API, or it could be called directly through one of the mobile SDKs. But now let me jump over and show you a starter kit, kind of like Jennie had shown you earlier, for getting started with a Kubernetes application. So again, on our Apple console, which is right here, I'll make the link really big at the end, console.bluemix.net/developer/Apple development. We have a number of starter kits that are specifically intended to generate production-ready code that you can use to get moving on the cloud, get started on the cloud, be productive on the cloud, and not have to worry about scaffolding out all of your infrastructure. It gives you a complete solution that you can start working with. And one of our new ones is functions with data. So there are instances of this starter kit. I'm going to show you the Swift one right now, which is going to create a set of Cloud Functions actions written in Swift. But we also have this starter that supports Node.js and Python actions. So we can come in here, we can read details about this, what it's going to create for us. And then when you go ahead and create app, you just need to give it a name, tell it which region you want to deploy into, and region, organization, and your space. And those are just how it's going to be logically organized within your account on the cloud. And then you hit create. I've already done this for the sake of time, and it's created an instance of our Cloud NoSQL database. It's created actions for create, read, update, and delete for the Cloud database. And then I've also created a DevOps toolchain, so that DevOps toolchain, if we come over here, creates a Git repository, which contains all of my actions, which I'll show you in just a minute. But it, in addition to the Git repository, it also created our toolchain and delivery pipeline, so that anytime I could make changes, I could be editing these files locally, do a commit to master, that triggers a new deployment, and that deploys everything back up into the Cloud Functions environment. So let me jump over here so we can kind of look at what's produced. And we'll just look at our read all action here. So this one is actually written in Swift. Can you guys actually read that? Probably not. Where our main function, come in here, it receives the input parameters. They come in as basically a JSON object. We're parsing it out, looking to make sure that we have our database URL and name, and those are coming from bound parameters, so that I don't have to have a secure database connection URL in every single request. And then we've got the logic to come in here, read from our cloud database, and then return those back to the requester. So let me jump back over, because you know, we can look at code all day. What I think gets really interesting is when we start to look at the Cloud Functions environment. So within my Cloud Functions environment, you can see I've got my package right here, functions with data, Trice, and we can see all of our operations that are here. And if I wanted to go in and look at any one of those, you'll see code that you can edit, which is the same code that we were just looking at on the desktop a minute ago. But if I go back and we click on APIs, as part of our deployment from the DevOps toolchain, it's also gone ahead and created entries for the API gateway for each one of those functions. So if I click on my functions with data API, right here we can see analytics and logging. So I haven't been actually hitting against it, so there's no data showing in the analytics and logging. But we can turn on rate limiting, we can turn on and off security, we can share or hide the APIs to make them exposed to the public. It will generate Swagger or Open API docs for us, so if we want to give that to other systems to be able to consume or be able to do introspection or code generation on top of that. And you can see here in the definition, here are all the operations on that API that were generated for us. So literally that starter kit created the database instance, created all these operations for us, set up our gateway, and it was all within 5 minutes, all of this is done for us. So it's now a REST-based API you can access if you want through any browser, through any mobile application, but I want to show you something, and this seems a little bit like magic, but it's so cool. So I'm going to go back to the Apple console, and we're going to go, instead of doing, we'll go back to starter kits, and I'm going to create a new mobile app. And we'll go ahead and hit create. So all this did was create basically an empty shell of an Xcode project for an iOS app. And I can come in and I can start adding resources to it so that when I download the code, assets based on the resources that we select in the cloud will be injected into that the Xcode project, so we can just start calling them. So I'm going to go to add resource, and I'm going to add an API. And the API is going to be based on the functions project that we just deployed. So it's right here. We'll call it functions with data, or it's called functions with data, the one that I just showed you. That's a bug. My session is not expired. We need to fix that. Where did my product go? This has got to be it right here. Okay. So here's my project. I need to go back and fix that bug. And now I'm going to download the code. And I'm not going to step through every single line of this code and go ahead and add in function invocations, but I wanted to just show you that by creating a Cloud Functions API, setting this API in here and using it with our starter kits that do scaffolding and to get your projects moving faster, it also generates all the support files and a mobile SDK that can be used to call this. So you don't have to do any kind of like inspection of the REST request or the Open API document to figure out what it's doing. You can just call it as method calls to a Swift API. So we jump over here. Oh, no. And just do a pod install real quick for that to make sure we have the dependencies. And then we'll open up our workspace. And I'm not going to go through everything here, but if we look inside our project, there's an SDK functions with data. And this is actually an SDK that was generated based on that Cloud Functions API that we just generated. And if we go into the APIs and we look at the default API, we can see we've now got Swift functions which handle all the networking request response for all the method calls that we just exposed. So there's delete, delete all, read all, create, and of course, update. And I think it said delete in there too. So anyway, that's pretty much it, what I wanted to show you. It's a real fast overview of Cloud Functions and kind of what we can do with Cloud Functions to enable mobile developers. We invite you to learn more, ask questions. Anything that we can help you guys do, we're more than happy to do that. And here's links for everything. I will put this out on Twitter also, or you can ping either Jennie or I on Twitter. Our Twitter handles are at the bottom. I'm Andy Trice. Jennie is J. King Oliver. And thank you. Any questions? I'm going to twiddle my thumbs. All right, yeah. Yeah, they're recording it, so.
You guys, thank you for the talk. It was great. But you guys have kind of presented two ends of the spectrum. Can you comment perhaps on marriage of the two? In some ways, we can maybe leverage both.
Sure. So they can be used essentially interchangeably. So especially if we're calling it from a mobile context, because most of us are probably mobile developers here. At that point, you're just calling them essentially as services. So it doesn't matter if you're calling a Kubernetes service or a Cloud Function service to deliver your information. But you might have existing systems that you need to just move to the cloud, and that might be an instance where you want to put it in Kubernetes and deploy to the cloud. Or there might be something where you need to do, let's say that's serving like user information or some kind of legacy data, but you need to do add new functionality, and it's very specific to whether it's real-time, event-driven, or access to another system that the existing system doesn't know how to talk to. You can add them, use them together. You could have the existing system talking to your Cloud Functions or the mobile app talking to Cloud Functions directly. As far as the systems are concerned, there's no reason they all can't talk to each other the same way that your app might talk to an API right now. So they really can be used for whatever you want it to be used for. Mm-hmm. Sure.
So we just, the talk before was a core data talk, and I'm wondering whether one of the things that you can do serverless is to use your database system as a backing store with core data, if those are alternatives or if they work in conjunction.
So, as far as them work, I mean, they can be used together. It depends what you're doing with core data and how you want to use it. You can be populating it from another database. If you're just reading and writing everything to core data and it's only in the context of your app, I mean, its core data is going to be really for your app. And if you're using CloudKit, you're syncing everything, that's going to be specific to your app. You could populate that with stuff from our database. So they could work together, but it would be more up to you to say, this is data I want to read, and this is how I want to inject it, or store it into core data, or something like that, or I want to take something from core data and put it into our database. Our database is, so the one that I showed is Cloudant, which is a NoSQL database, is accessible to any platform, any language, basically anything through a RESTful endpoint. Core data, I haven't spent as much time with core data lately as I have with Cloudant, so hopefully I'm not wrong when I say this, but core data is still limited to just iOS specific? So that would be the difference there, is if you want to go beyond iOS and you want to be able to access by different kinds of servers, different kinds of systems, then you would want something like Cloudant or a relational database and take advantage of it in those kinds of operations. Don't let me hold the mic.
Hi, I know you can run Docker containers and Kubernetes locally for development. Can you also run serverless functions locally for development? And if so, how hard is it?
So essentially, the answer is yes, you can. And essentially, it's just like an executable on your machine. So like a node-based serverless function is just a JavaScript file. So you could still run node and pass in the file name, node file name, and it's going to execute. The challenge might be is if you have parameter bindings, then you need to, on your machine, simulate parameter bindings, which means you just need to pass in parameters that match whatever it's going to be expecting in the server environment. So if you need like your database credentials, something like that, you need to make sure that that gets passed in. I know that there have been community-driven efforts from the open source project to do like spin up a local instance, which is lightweight, that mirrors kind of like the cloud instance. I don't know how mature those are, but I know that there's efforts from the open source community that have tried to address specifically that, so that you don't have to write essentially your own like host logic on your machine yourself. But everything that you're doing on there, it's basically, it's a JavaScript file, it's a Swift file, or it's a Python, whatever. It can be executed on your local machine also. That said, it is slightly different than, let's say you have a Swift Katura app. You're going to run Swift Katura on your local machine pretty much the same way it's going to be run in the cloud. The difference with Cloud Functions is you're not just telling a server to start. You have individual files that you need to be making requests into, essentially.
All right, that's it for questions. Thank you very much.
Thank you, everyone.